Okay, so we have a non-conducting spherical shell. With an inner radius of 4.1 centimeters and an outer radius of 7.8 centimeters. And there's charge spread non-uniformly through its volume between its inner and outer surfaces. The volume charge density rho is the charge per unit volume. So for this shell, rho equals B over R, which is 3.8 times 10 to the minus 6 coulomb per meter squared over R. So what is the net charge? So if we look at some R in the shell, then at that R, our charge is going to be let's try this again. Our increment of charge is going to be the charge density times the increment of volume. The increment of volume is going to be, so if we look at some small shell, right, then it has a thickness of dr and a surface area of 4 pi r squared. So it's going to be 4 pi r squared dr. So whatever the rho is at that r times our surface area times our dr thickness. So then our total charge is then the integral of this expression from Ra to Rb. And now our rho actually depends on distance, so that's 3.8 times 10 to the minus 6 coulombs per meter squared, integral Ra to Rb of 1 over r times 4 pi r squared dr. So we can bring out our 4 pi. And then cancel one of the r's, so it's Ra to Rb of r dr. And now our integral rules, we just raise the power by 1 and then divide by the factor. So r squared over 2 from Ra to Rb. So we get 2 pi and so then that's Rb squared minus Ra squared. And now our Rb is given in the question as as 7.8 centimeters, so that's our outer radius, times 10 to the minus 2 meters squared, minus, and then 4.1 centimeters is our inner radius. And so this comes to 1.051 times 10 to the minus 7 coulombs. So that's our net charge in our shell. Checking the solution here. Do our integrals. And it comes out to 0.105 times 10 to the minus 6 or 1.05 times 10 to the minus 7. So, looks good. Okay.